Hi, welcome back. This is the second part of the lesson on generics. In the previous part, we saw the basic usage of generics and what generic classes and generic interfaces are, and how we can use generics to make our code compile time type safe and avoid typecasting. Now, in this section, let's look at some of the advanced use cases of using generics. So let's get started. So let's go to the class that we were working with. In this class, we've seen that we made use of generics with integer, the formal type parameter being integer, with list and array list. Now let's say what I want to do is this. I want to design a method which would sum up all the numbers in that list and maybe print the sum of those numbers. How do I design such a method? Now, to design such a method, maybe a design public static, because I want to call it from main. Since it's going to print the value, I won't have a return type, void. Let's say sum. Now, can I make this method to take a list L as argument? Now, some implementation in the body. So it's not really about what goes in the body, it's more about the signature of the method. Now, can I pass this numbers as an argument to this method called sum? So can I call sum and pass this list of integer numbers? Well, it turns out that I can, because this sum method expects any list. In fact, we've used raw type. But the problem that arises out of this kind of a definition of the sum method is, what if a list of non-numbers were passed as an argument? Let's say I create a list of string called names equal to new array list of string. Now, can I call this sum method and pass names as an argument? It turns out I can, because sum really expects any list as an argument. So what if I wanted to restrict that sum should not accept a list of string or a list of customer or a list of some non-numerical type as an argument? So in that case, what I'm going to do is, probably your first attempt would be, well, this numbers is a list of integer. So let me change the signature of the sum method to accept a list of integer. So this can give us immediate relief in the sense that it allows invocation of the sum method with list of integer, because now it takes list of integer, but it's disallowing invocation of the sum method with a list of string. This is what we wanted to achieve. But there's more to it. Now, let's say I have a list of float. A list of float called f numbers equal to new array list of float. So you see, I'm using the diamond operator, which means it'll infer the type of the type parameter from the left hand side. So this is a list of float. Can I call this sum method with this f numbers as an argument? Well, it is disallowing that, because now we say in the definition of the sum method, we have said that it allows only list of integer, but we're trying to invoke it with a list of float. But don't you think it makes sense to even sum up floats or doubles or longs and shorts? All of them are really numbers. So this summing up should be really applicable for all numbers. So how do I redesign this sum method in such a way that it doesn't allow list of string or list of customer or any such non-numerical values, but allows list of integer, list of float, list of double, and so on? Well, it turns out that in Java, all these numerical wrapper classes such as integer, double, float, and all of these wrapper classes inherit from a common base class called number. So can I change the signature of this sum method to take that base type number as an argument? Let's try that. So I'll change this to number. Once I've changed this to number, you can see that I'm neither being able to pass list of integer, nor am I able to pass a list of floats. That is because when it comes to generics, it's as if the inheritance relationship between the classes being used as formal type parameter doesn't matter. Which means if you have a method which accepts list of number, I can only pass list of number. I cannot even pass a list of integer, integer being a subtype of number. So what should I do? So what I want to say is, in the definition of the sum method, that this method sum takes a list of any type that is a number, any type that is a subtype of number. So to do that, we have the concept of wildcards. So I'm going to use something like list of question mark extends number. So which means I'm now saying that the sum method takes a list of an unknown type, but some type which is a subtype of number. So now you notice that this function called sum, we're able to invoke using a list of integer, using a list of float, but not using a list of strings. So this is what we mean by using this kind of a wildcard. Similar to how we have question mark extends number, I can also use question mark super number. That would have meant it would be a list of some type which is a parent of number. So that would have meant only object. So this is what we mean by wildcard.